Hi, my name is Greg Wagner. I'm an AI expert, and I'm going to go into explaining what AI is. AI isn't robotics. Well, you can have AI with robotics. It's not necessarily any type of basic computer program. It's something else. So, AI, as I define it, is a system that can perform human-like intelligence behavior. Doesn't do like humans do. It can do actions that humans can. And so stuff like recognizing speech, we can do that since we're babies. Driving a car, I can drive a car. Recommending movies, I can ask somebody to recommend a movie for me. Generating text and writing, which we can do. And identifying faces, which humans are very good at, and we can train AI to do that. Those are all definitions of artificial intelligence. They're different branches of AI, but there's still definitions of it. Adding two numbers together, maybe not AI. Cleaning up an image, probably not AI. So it's kind of fuzzy about what things are. There can be stuff that computers do that better than humans, that humans can do. And those aren't necessarily AI. So the definition is a little bit fuzzy. But we'll go over this, starting with kind of the three basic definitions of AI, and I'll tell you which one I think is the most likely. So going into a little bit more depth, what makes AI different from the normal software? So say you're running a small business and you need to calculate what your taxes are. You use a computer program to do that, or your accountant will use a computer program to do that. That necessarily isn't AI. It's doing mathematics, and it's doing something a human can do, doing your taxes. But it isn't necessarily AI. And the reason why is because when you do your taxes, it's going to follow specific rules, and it's going to do exactly what the hardware is going to do. And the programmer writes every instruction. When something becomes AI is when the computer does stuff that it does interpretations that are outside of very, very strict rules. So if you had a tax application that maybe tried to interpret the tax code, that's when it would start falling into AI. But if it's just following the rules exactly like you would with TurboTax and not giving you guidance, that is not AI. Or you have a system that's following the law exactly. That would not be that would be software that's looking at and trying to look at the laws and say, okay, you can do this, you can't do that. But if something goes in and acts more like a lawyer and tries to interpret a law, that's when it becomes AI as well, in my mind. And so regular software, basically you give it inputs, it goes onto your chip, your CPU or your GPU, does a calculation and gives you back answers. An AI system will add a little bit elements to it. It takes advantage of the memory on the computer, so we'll start learning patterns. So as you're typing and stuff, like like for generative AI, it looks at what a bunch of people have written and then tries to generate stuff matching that style and text. It can make predictions, or it can also classification of something. It can identify something. And then also it can adapt to as you get different examples and do adaptations over time. Those are all kind of traits of AI. And so one thing I need to mention is a lot of times AI systems require a lot of data to make these predictions. Generally, a basic software application has these rules and doesn't actually need a whole lot of data. You might have some data to test it to see if it works, but you're not using data to build your what we call models or ways that the AI system is trying to interpret stuff. These models are adapted based on the data you have, or sometimes adapted based on the data you have plus something that a user generates. And so say, for example, you want to identify a cat. You and I, we can learn what a cat is by just seeing maybe one or two pictures. An AI system would need to look at thousands or tens of thousands of pictures of cats. Then they can identify that. It's basically look for patterns, pointy ears and stuff along those lines. And so, again, AI is different than regular software in that it tries to identify patterns or tries to do some interpretations of stuff that are beyond the original rules developed by the programmer. There's essentially three types of definitions of what AI is. I'm going to go through through the ages of what they are and which ones I think it is. So the first definition of AI, and this is kind of going back to, if you think more along to philosophers of artificial intelligence, stuff like that, is pretty much all computing is artificial intelligence, because computers are designed to take place of what humans are doing. And so all software basically extends human thinking. And that's kind of the idea, is it's artificial intelligence because it's acting human-like. So calculators with math are AI, spreadsheets are AI, face recognition tools are AI, databases are AI, because they extend the way that people think. And so a calculator, has math and has memory like a human does. A spreadsheet does basic reasoning and some sort of data processing like a human does, very much like an accountant. And databases basically extend knowledge. You store it like a librarian would do. And so while this is an interesting philosophical idea, I don't buy it. Mainly because, it's most of these systems are not actually thinking. They're just reacting the way, or, no AI can really think. But basically, it's not acting intelligent. It's basically just doing something that the hardware and some of the software is doing. So this first definition, while it's kind of interesting for philosophers, it's generally most computer scientists don't really buy this idea. The second idea in computing, and this is something that my PhD advisor, essentially my boss when I was getting my PhD, thought AI is. And he considered AI, and lots of other computer scientists consider that AI is anything that's really just cutting edge as far as software projection, as far as doing some sort of like predictions or classification. And the idea is AI is kind of just a generic term for whatever is cutting edge, and as soon as it becomes commonplace, has a common name, it no longer becomes AI. So, for example, my area of expertise for my PhD was computer vision. And so my advisor did not consider computer vision AI because it had a name. It was called computer vision. And so the idea is as you're kind of growing the space of AI, or as you're growing the capabilities of computing, everything that's really cutting edge is going to be AI. And as soon as it starts getting conferences and books named after and stuff like that, it is no longer AI. And some people still believe that, but kind of the last term is kind of the most common one, where AI is an umbrella. So the definition that I think AI is, and most people think about it as now, is AI is a big umbrella. AI basically includes a lot of types of techniques that fit the definition we talked about earlier, where you have a software application that does some sort of processing that isn't like exactly written, does some decision based on different examples and seeing stuff like that. For example, my PhD expertise was in computer vision, which would fall under AI in this category, where we're using examples of different images to make generalizations, to make classifications and predictions based on looking at new images. You have fields like machine learning, which collects a lot of data and includes neural networks, which is a really hot field. ChatGPT falls under the kind of the neural networks, machine learning type of category. Robotics, which is, I think, is going to be the next big area in AI, based on advances we're having in the actuator hardware as well as in the software processes. Knowledge representation, which is using like trees, and expert systems that also falls kind of under the knowledge representation type of thing. I think this is the definition, where AI is kind of a bunch of different categories, where sometimes we're trying to combine these together. When I was getting my PhD 20 years ago, machine learning and particularly neural networks and computer vision really didn't work together that much. We used different techniques, but now most of computer vision uses machine learning techniques. And things will probably change as we go into the future, as hardware gets better and we get better applications, better sensors and stuff along those lines. So AI, is becoming very ubiquitous, and as time goes past of the release of this video, this is just going to seem more and more quaint. But AI is very, very good at many things. It's good at learning patterns and doing recommendations. Think of Netflix and Amazon recommendations. They're very good based on what you purchased before, what you watched before. It's very good at fraud detection. They basically determine if you have different patterns as far as your purchases go. They're also very good at doing image processing or computer vision, which includes image processing. They're very good at doing generative AI techniques like ChatGPT as far as generating text and images. They can do a lot of things pretty well. One thing I like about generative AI is you can write software very, very fast. It's not as good as I would write it, but it's a lot faster than I would do it. There's ideas behind what's called like symbolic AI, which includes expert systems and knowledge graphs, basically having rules and regulations to follow specific paths. And there's also stuff like discovery, like you do with a field called evolutionary AI, that looks to try to find new paths. You can do that for like whether it's trying to find new materials or new drugs and stuff along those lines. That can do a lot of different, essentially, experiments, and that would take usually humans years to do. We can do them digitally, do pretty good solutions. So AI is changing the world around us, but it's very good at stuff. But there are downsides to AI, and there's stuff that it's still not going to be good at. And I don't know if it's ever going to be that good. So AI is not magic. It can't solve all of our problems, but it can, but the limitations we're pretty aware of, and we're trying to work on fixing them. Some of these issues with AI include hallucinations, where especially with generative AI techniques like ChatGPT, large language models is an example of those, and image generation, like with DALL-E and other diffusion models, image generation techniques. They can do what's called hallucinations, but they'll say with a lot of confidence that this is the answer they think it is. And neural networks are particularly bad for this, but they'll basically generate a solution saying this is the right answer, but it really can't explain it. So there's a field of AI called Explainable AI that's going to try to fix some of these things with hallucinations, at least try to explain how it got the answer and let a human determine whether it's hallucination or not. This area is still fairly new, and it's kind of still building on it. AI also has biases, so a lot of it's based on training data. So if you have training data that's biased towards one racial group or towards one neighborhood or towards one thing in particular, it's going to have a bias and select that more often. Think about if you have a system that's going to looking for cats, you train a lot of cats, but you don't train on as many dogs. It's going to be a lot better at identifying cats than dogs. And so some of this bias is due to negligence from the algorithms, but also collecting data is very expensive, and sometimes you might have data that just is missing a hotspot. So that's an area that we need to work on. Some of the issues with reasoning aren't good. It can't really, if it sees data it really hasn't seen before, along with bias happening. And also for reasoning models, if it sees data it can't have before, it kind of melts down or picks paths that maybe it probably shouldn't have. And then also, AI is not human. It does not really truly understand what it's doing. It's just basically, for stuff like GPT, it's using basically statistical models to do this, or for stuff like knowledge representation, it's using following rules and paths and stuff like that. It doesn't know why it's doing this, and so it's not really human-like. Humans, we can at least, maybe we can't explain well, but we at least explain what we were thinking when we did something. AI really can't do that. It's going to just basically follow a formula and go through with it. And then also, AI does not have, along with not being human, doesn't have any common sense. It doesn't, can't do very broad generalizations of data it's seeing. It will kind of follow whatever rules it has. And if there are cases where, just stuff that you and I would have as we mature and grow older, it doesn't have that experience to kind of build on stuff, of just general seeing of stuff that we absorb every day, day to day. And so these are areas that we need to work on. And in my humble opinion, I don't think AI is ever going to match human intelligence, because I think we don't really understand how the brain works and how people learn and understand fully. And how can we program a computer to do that if we're never going to understand that? So to wrap up, just to repeat what I've said before, AI is meant as software that is attempting tasks that we associate with human intelligence. It's not trying to be human-like, it's just trying to complete tasks like a human could do. And so in subsequent videos, if you want to watch them, we'll go over more into this. I'll follow up this video with a video on the philosophy of AI, which I find very fascinating. One thing I like about AI over computer science in general, like software engineering and systems programming type of topics, is there is a philosophy and there's kind of ethics that we can kind of build into this, which makes it a very exciting field, not just for computer scientists, but for ethicists and people that are more interested in the humanities. Also, we'll have more technical videos. I have a video going over the 5 tribes of AI, and we'll go into a little bit more depth about some of the mathematics as far as AI going forward. So thanks for sitting through this, and I hope you have a great rest of your day.